extremely exciting session where we're going to be talking about the state and future of generative AI. It coincides perfectly with what is just about the first year anniversary of the release of ChatGPT. And thankfully, nothing at all of any sort of drama is affecting OpenAI and ChatGPT as we speak. Of course, I'm joking. Everything's really exciting and we're all riveted to what is happening there. But with us today, we have a phenomenal guest, arguably the best person to go in and be thinking about and taking stock of just where are we when it comes to generative AI and what we need to be doing. And I am, of course, talking about a person who has had a front row seat at the generative AI revolution, but also the data science revolution broadly. Someone who has been a titan of the open source community and really a driving force behind open source based data science methods. And I'm talking about Peter Wang, CEO and co-founder of Anaconda. Peter, thank you very much for being with us.
Thank you so much for having me. Yeah, and that's a very flattering introduction. But it has been really exciting to see how this stuff has taken hold and how open data science went from being a very small sort of arguably niche revolution to then transforming entire industries and then laying the groundwork for what is now, of course, probably one of the biggest technological transformations for humanity in hundreds of years, thousands of years, who knows? I mean, it is a very exciting and interesting time for sure.
Well, and I think we have open data science really to thank for this, because really that pace of acceleration that we've gone through, I think, is entirely based on this. But going to that point, generative AI, obviously everybody has their perspective on why it's so important, but a lot of folks have a perspective that isn't necessarily informed by the actual technology. I would love if you could share just why you think it's so important, why no organization can be ignoring this.
Well, I think the interesting thing that's happened is we're just now, you mentioned OpenAI, right? We're just about a year into the ChatGPT release, right? And what's so interesting, I guess, is that this whole thing actually started happening a few years before, right? Not only the transformer model being released, but even GPT-3 itself was a couple of years old when they released the chat interface on top of it. Now, of course, prior to that, for a while, people have been kind of, I would say, hyping up AI. And it really, to me and to certain others in the machine learning space, it seemed like they were just putting a suit on machine learning techniques and calling it AI, right? But what was interesting about ChatGPT, and then, of course, Stable Diffusion and DALL-E and sort of generative AI, is that it opened up this completely different frontier, that we went from just having a smarter predictive system to something that does tasks that we had previously thought of as being really in the realm of humans, right? Writing a bunch of text, writing a rap song like Eminem, drawing a picture. These are things that it took humans or Eminem to do. But it turns out a bunch of matrix multiplication also can do it. And that was, for people like me, the really stunning thing. I've been interested in machine learning and AI since when I was in high school. So it's been decades now that I've been tracking through the AI winter and all these things. And really, I think the big thing that changed with generative AI is that it was a very tangible and accessible thing that anyone could look at and say, this is a computer doing something that I've never seen a computer do before. And I would say it's almost at a meta level is equally impressive to experts and to novices. And I think that's the really interesting thing about it.
Well, there are a couple of things in what you said there. One of them was that, well, to a certain extent, ChatGPT might not have been really a technological evolution, but it was an evolution when it comes to the experience of it. It was something that everybody could use. There's an element of the sociological phenomenon around it. It's like, yes, okay, so we've had transformer models since 2017, and folks have been using it, but it's the first time that folks have viscerally been able to experience it, and folks outside of the data science community could experience it. So it sounds like one of it is that element of it. There's probably an element of just maturity to this. Like, so thinking about, the late 90s wasn't when we invented the internet, right? It's been around for a long time by that point, but that's when it took off as a mass phenomenon. So it feels like yes, generative AI, there have been some technological breakthroughs through it. There are things that were more powerful potentially in GPT 3.5 than in GPT 3. But really, this is just as much around the mass movement as it is about a specific technological innovation. Is that roughly right?
Yeah, I think so. I think so. Because there were, when they put the Instruct GPT data set together and they had the reinforcement learning through human feedback approaches, those were things that they bolted on top of the underlying GPT-3 model or 3.5, but I think ultimately what caught people's imagination, and I don't know how many people know this, but when they released ChatGPT internally, they didn't have any idea it was going to blow up the way it did because GPT-3 had been around for a while, right? So people, I mean, friends of mine were playing. I was not playing with it myself, but I had friends who were doing a lot of interesting things with it. And they're like, oh, these transformer models are quite powerful. But ChatGPT came around, and the fact that it would talk to you, it would talk back. It's sort of the standard 1980s ELIZA trick, but way more powerful. And that form factor, it hacked something in our brainstem, I think, from a UX perspective, right? And I think that's where the generative part of the generative AI has really captured people's imaginations. And then once you start looking into it and you realize, wait, these underlying models capture a lot in those embedding models. There's a lot of information there that we before would have to work very hard to formally structure, and that's latent in there. And so now we can actually program these things almost with just words, and that's a completely different thing then, right?
So there's an element of this being that it's also changing the way that we interact with technology, so that now and data generally. So now, if we want to understand data, if we want to work with data, if we want to create applications or engage with applications, now we've got another modality in which we can do that in a way that was very difficult previously. I'm guessing.
Yeah, it's still very crude right now, right? And I think for me, this year has been one of great learnings. Because on the one hand, people like me and others who've been in it for a while, or who can understand, kind of what it's doing, the math at least, people like us are impressed by what these things are doing. And then there's the backlash of people who are saying, well, this is overhyped. It's a stochastic parrot. It's hallucinating. It's not very good. I asked a question about something I have knowledge about and didn't answer correctly. And it's like, the fact that it gave a comprehensible answer at all is amazing, And so it's just been all these different iterations. But I think the really important thing here is that for how crude and how early the technology is, it's already able to do amazing things, do things that we could not have done with a computer, I would say a few years ago. And that should cause everyone, I guess this is kind of the whole context of our conversation here, is how should people be thinking about the impact of this technology in their business, in their personal lives even. And I think the first thing is that many of the paradigms that we're used to thinking about computing, that we use to think about computing, those paradigms are all going to change in dramatic ways. And the software interface is the first of these.
So it sounds like that paradigm changing in the sense of both the way that we're engaging with technology and how we're using it, but it also sounds like also the class of problems. There's ways in which these models make it possible to leverage unstructured data, voice, images, video in a way that we really didn't have a scalable approach. We could do things with those types of data if we spend an awful lot of time and effort going in and manually structuring that data. But this reduces the barriers to entry on that dramatically, it sounds like, both on terms of range of use cases, but also in terms of how much you can do within each one of those sets of use cases.
Yeah, it really is. One of my favorite go-to quotes from a famous computer scientist named Alan Perlis that I've loved for years was he had this great quote that you can't proceed from the informal to the formal via formal means. Right. And it's just a nerd way of saying you think you got a beautiful, elegant system, but the gnarly bits are the gnarly bits over here. And it takes a human to really take the gnarly bits and turn them into a schema or turn it into a business specification or turn it into a YAML or whatever. And actually, I've loved to throw that quote around for decades now. And now I have to stop because LLMs can get us halfway there. Right. It's kind of amazing that one of my favorite Perlis quotes is now going to have to get retired soon. I can already see having to sunset it because you can now proceed from informal to somewhat semi-formal sort of specifications and things like that. And it's amazing that it works. And again, it's not like the code for the model is telling it how to do that. It's that it's latent inside these giant, massive billion parameter matrices. Somehow the meaning and the information of all of humanity has been encoded into this. And that's the magic of it. Still wonderful, still amazing to think about.
Well, generally, I'm always astounded at the way in which these models are able to teach us about ourselves. Unfortunately,
Yeah.
occasionally they teach us terrible things about ourselves. But in terms of, well, just so how much are we actually thinking and reasoning about our own decisions versus how much of this is us just predicting what our next word should be or what our next action should be. But I'm struck by something that you were saying when it comes to the misinterpretations of these models and how we should use them.
Mm-hmm.
And it sounded like a little bit of algorithm aversion and rubber stamping on steroids, i.e., the person is like, well, okay, the model hallucinated, so therefore I'm not going to trust any of it, which obviously isn't the right approach to take. But on the other side, there are folks who are perhaps not thinking as critically about whether or not these models are going to perform to the standard that's necessary for an enterprise-grade application. And so there's an over expectation, an over rotation on terms of what we could actually do with them. Should we be aiming for some sort of middle ground, and this is likely always going to be a human-machine interaction?
Well, yes, but maybe my yes doesn't mean quite what you think it means. And so I would say the answer is that more sophisticated tools require maybe more sophisticated usage. And there's a hilarious recent episode of Rick and Morty where Morty gets a lightsaber and he actually drops it straight vertical, and it starts boring its way into the middle of the earth because it's a lightsaber. And so, you wouldn't do that with a iron sword, but with a lightsaber, unfortunately, it can do that, right? And so, maybe sort of a bit of a comedic turn on this, but the fundamental point is that we should, just because it's more approachable, doesn't mean that it's also going to pad you from making worse mistakes. It might let you go and get really wrapped up deeply in some really bad mistakes. I don't know, right? With many other kinds of physical technologies, we don't shy away from this reality, but somehow when it comes to computing technologies, we have a certain, I don't know if arrogance is the right term, but a certain expectation. Oh, it's friendly. I know how to click on this. I know how to click on that. I don't have to read the manual. I clicked on these buttons and it gave me an answer, and this plot looks basically right. And that sounds good to me. And it's like, well, it doesn't tell you what you don't know because it doesn't know what you don't know. You have to be responsible for managing your own level of ignorance and level setting that correctly to it, right? I mean, imagine if you made a Boeing 737 really easy to climb into the cockpit and really easy to take off, but there's no autopilot for landing. Now what do? Right? There's a one-button takeoff. It'll taxi itself off, radio the tower, take off, and now you're in the air, autopilot turns off, and now you're stuck, right? Or you're not stuck. you're in a bad situation. So I think with these tools, we got to be careful that making them more accessible on the front end might actually make people inappropriately index one way or the other, to your point. They might just write it off altogether, or they might just start treating everything it says as gospel. And, it doesn't even take AI to see this particular kind of cognitive problem. It happens with spreadsheets, which we've had for 40 years, right? I mean, spreadsheets are not magic, but there's many people who just worship the spreadsheet because the data is there. It's a number. They believe the number. And they don't really think deeply about what are the variances and what are the bounds on error as these things flow through the spreadsheet. So, and I've seen that firsthand more than what I care to count. So I think with AI, it's going to be a similar problem, but possibly exponentiated, right? Because the AI will explain to you why it thinks it's right. And if you don't know how to really double check, now you're going to really be in trouble.
So the great thing about this technology is that it's super convenient, and the terrible thing about this technology is that it's super convenient.
Super convenient, yeah.
And we don't do our due diligence around it. I do want to touch on that point, though, around generative AI and AI broadly. So there are folks who believe that, okay, this is generative AI, this is what I should be focusing on. I don't really need to be thinking about my traditional data science efforts or those machine learning projects that we've been going after. Really, I should just be paying attention to generative AI because that's the way of the future, or something along those lines. I can't imagine that you would be a believer in that, but I would love to get your thinkings about that intersection and that interaction between generative AI versus quote unquote traditional AI and all of the standard machine learning methods that we use for processing structured data.
Yeah. I think there's going to be a class of problems where generative AI is its own kind of thing that does its own kind of thing and is fine. Like if you have it as a chatbot, you have some APIs you tie into some of your documentation or knowledge base, and you want to have a chatbot going, and that's okay. Like that's probably you know um, that's a fine thing to sort of think about in its own structure. But when it comes to actually using generative AI to go deeper into business applications, into data modeling, into predicting and understanding the business, or things like that, I think it's a crawl, walk, run. There's no free lunch here. If you look at what actually powers what's underneath the hood of this thing called generative AI, it's a lot of the technology stack that is in that you encounter in traditional machine learning, oftentimes with GPUs. But now we're seeing models get smaller and run on CPUs, so you don't necessarily even need GPUs for some of the serving. So to be good at managing and governing and rolling out generative AI, it's no different than being good at ML. And actually, the part that is hardest is it's the human factors and organizational problem. Getting other people in the organization access to the data and access to the infrastructure, empowering your IT folks to be able to serve this kind of infrastructure to more than just the data science and machine learning engineers, but to lots and lots of people in every line of business, right? So it's really the nature of what you have to do actually is very similar to what had to get done for data science and machine learning, all the ML ops stuff, all that stuff. Good news, if you've been working on it, it's the same thing. Bad news, if you haven't been working on it, you better get good at it, because it's going to be the same thing, but with new layers of problems on top. But it doesn't take you away from those problems. And I do think some people are going to want to hit the easy button. This is what we saw with data science as well. Like, you know what? This is just all this Python and R stuff and all this open source stuff. It's too complicated. Notebooks and what are all these things? They want the easy solve button. And the problem is anyone who gives you an easy solve button is your competitor. They're not like, they're going to get your actual, the good vendors that support you are the ones that are going to help you manifest your capacity or develop your capacity to actually do AI. If someone gives you an easy AI solve button, they can only do that well if they have your data, in which case they have all of your upside too. So yeah.
Yes, well, I guess
maybe that's a little spicy, but I just feel like it needs to be said, because there's a lot of people who just want to buy the tech, and this is not a tech you can buy. This is a transformation of the business. This is actual real business transformation you have to do.
Yeah, well, I was often wondering when it comes to generative AI, whether or not embedded in why folks are so excited about it is that they're also excited about the possibility of being able to outsource all of this. It's the misguided hope with AI generally that AI will somehow automatically figure this out, that AI will do the thinking for us, that AI will do the hard work for us. It's just a different version of this. It's okay, great. With these generative AI models, they're going to be so powerful that I'm not actually gonna have to do a whole lot with it. I'm going to go in and let this third party go and develop these models and host these models for me, and then I can just worry about the prompt engineering and maybe the front end development. And I've been skeptical of this because I remember the AI APIs of the 2015, 2016, where it was like, oh, the Watson AI APIs and the Google Vision AI APIs and the SageMaker recognition, or I guess it was just AWS recognition APIs back at the time, where it was they were powerful, they were incredible, but if they were based off of the belief that I could outsource the model to a third party, that they wouldn't really have to do a whole lot of additional fine-tuning based off of my own data, that I wouldn't need ownership over these. And they never took off. And I see the exact same characteristics when I look at the models being offered as a service by OpenAI and every one of the cloud vendors. And what are your thoughts on the degree to which you can outsource this, and the need to build your MLOps capabilities or your LLM ops capabilities can be handed over to a third party? It sounds like, well, probably not so much.
Yeah, I think you're absolutely right. The early AI APIs that came out were very focused on certain topical areas. What we knew we could do some kind of ML at scale and deliver some kind of a result for a customer that you feel good about charging them for. but they were not really like generalized AI kind of things. And even text processing was very much, I would say, low level natural language processing tasks like tokenization and things like that, some translation stuff. Um, and what's different now is that the scope of what you can do with LLM techniques, and not, it's not just LLMs. There's other kinds of network architectures that I think are going to actually supplant LLMs in the years to come. But all of these things or transformers rather, right? So some new things that will come along. But the point is that right now, the scope of what you can handle or that you could sort of tackle with AI is much larger. And so the bottom parts of that stack that are well conditioned, let's say, like a recognition task or a machine translation task or whatever, where you're based in ground truth that basically the whole world knows, then you can actually, I think, tend to rely on some of these APIs because they have access to roughly the same kind of data you're going to have access to if you build your own bespoke one in-house, right? So you probably should be using some of those APIs just to accelerate your development. I mean, there's no reason for you to have to develop a custom vision model to do some text recognition OCR kinds of things anymore. Just use the vision API unless you need to run it on-prem or at the edge, or you have sensitivities around data uploaded to the cloud. There's many reasons not to use one, but in general, those models are good enough for what you need to do. That being said, everything else above that, where your data and your business perspective and your domain context is actually really an important part of how you're going to make money or why you think you have a competitive advantage. Those things, a commodity off-the-shelf model or API is not going to give you those things. You're going to still have to build on top of that and figure out some way how to encapsulate your perspective, right, and your historical knowledge and the insight latent in your data. So you really can't, I don't think you can outsource that part of it. And the interesting thing is I've talked to, prospective customers and clients and whatnot, I think people do understand this very quickly, that there is a reticence to just upload everything to the cloud. There is absolutely understanding of like, oh, no, like my data, I'm okay to call APIs for certain kinds of things and whatever cloud infrastructure, IaaS kind of stuff, but my data is my data. And I'm people are more jealous of their data than I thought they would be, which is good. I think they should be.
Yeah, so it sounds like definitely not a one-size-fits-all approach. There are certain use cases where potentially you can leverage these models out of the box for a good range of an application, maybe even for an entire application. But it sounds like for a lot of them, especially the most important differentiated use cases for which you are looking to drive extraordinary value and competitive advantage and that are unique to your business, those ones you're not going to be willing and to a certain extent able to go in and outsource that to a third party, in part because of the data concerns, but it sounds like also because you're going to be needing to leverage these in a much more complicated fashion than what one of these third party models will have been designed to do. And indeed, it sounds like there's a broader story here about which your LLM, even for a generative AI application, is just part of a larger pipeline of different models and data engineering steps that you're going to need to have, that's a lot more complicated and that you need to have a lot more control over. Is that roughly right?
That's a very, yes. Thank you for summarizing that so well. That's exactly right. And I think the last part you talk about, I think, is a really great way to sort of segue to this concept that LLMs and whatever their future might be, it could be SLMs, small language models, right? People are trying to compress 100 billion, 50, 70 billion parameters down to 13 or 7 billion parameter models and trying to get, as good of a performance. And they're getting there. So I think we're going to deal with these like language model, general transformer kind of embedding spaces. They're one component of a new kind of information system. And the chaining of these together and the prompt engineering and the data engineering, as you talk about, those things are not going away. Those are new, those things stitched us together to make a new kind of information system. And we'll be assembling those systems, we'll be governing those systems in a different way at a higher level than the way we think about software, which is very functional, very like, here's my input function with these values, A and B and C, and it produces this output, which I put into this database here in this row. Like that kind of model of information system it'll all still be there too. We'll still have to do some of that, but a lot more work is going to be done by a lot more people at a higher plane, I think, in this higher dimension of building information systems with these kind of larger components, molecules instead of atoms, maybe.
Well, I'm curious on that challenge of, well, the challenges. Where are folks struggling right now? Is it at the, obviously there are a lot of organizations that are just getting started and going through a proof of concepts, but there are enough organizations that have moved to the next step and they're looking to operationalize this and are then running into that problem of how do I manage all of those different technology components that need to come together and work effectively, even though a lot of those technology components are very new and immature. Is the biggest challenge that we're running into right now and potentially for the next year one of that operationalizing these information systems as you describe them? Or are we or are we still struggling with we're still trying to figure out what the use cases are, or we're still trying to get approvals, or we're worried about regulation or some other challenge?
Well, it's sort of all of those. Maybe as a dodge. Maybe I don't want to punt on the answer. I think what I've seen is that people don't lack for imagination on what could be done with this, and different people are imagining different things for different reasons. Executives are imagining this because they think of ways to either directly, trim costs, maybe, or some who are more innovative and forward thinking are trying to think about ways this could deliver better, novel services to customers. Everywhere in the chain, people are thinking about how do I leverage this from that kind of perspective. But what I've read and what I've seen, I think what people are generally seeing in the industry is that there's a lot of interest. There's a lot of people exploring, trying to see what they can do, having open conversations with their legal departments about what they can do and can't do. These are real though, right? That as soon as you hit PII, as soon as you hit anything that remotely resembles crown jewel data for a business, people start throwing up, barriers and roadblocks, and appropriately so. So there is a lot of exploration happening right now, and budgets being thrown at it. I think the challenge is going to be that operationalizing it might take a little bit more work than they're anticipating. And it's going to take some executive air cover. It's going to take some deep thinking about some of these regulatory things. So the trough of disappointment, or whatever term we want to use, like there is going to be there's going to be a phase where people have exciting prototypes that maybe are quite performant. They get rid of the hallucination problems because they're using various techniques over here. They get rid of the inference cost problem because they use other techniques over here. And they actually build something that's like, okay, I think we could actually productionize this for more than just, again, a little chatbot on the website, but something, that really hits the business bottom line. Well, as soon as you have an information system or computing system that you want to put in production that does this kind of thing, businesses do have standard operating procedures that they go through. And I don't see how you avoid having to go through some of those checks. Again, unless the CEO is willing to put their, really C-suite level person puts themselves on the line to be responsible for that. So I think that's going to be our journey for the next few years, that the big businesses that are really trying to operationalize this and take this seriously, they're going to really hit some of the tar pits of deployment. Now, there's things they can do to get through that more easily. They can try to have more control over how they're running it. They can, from the very get-go, make sure they're deploying safe, secure, open source. They can make sure that they have all these things in place to facilitate that. But even so, there's still going to be discussions around the data and around customer interactions, I think, if they're in that kind of domain. But meanwhile, startups are going to YOLO it into there. And startups are going to give them a sense of urgency. So it's going to be a real interesting dynamic to see what happens. Because what we saw, over the last 10 years is that many startups are more than happy to just do a bum rush into regulatory, questionable regulatory situations, and some survive and some don't. So we'll see.
Well, it feels a little bit like what you were saying earlier, in that you can't escape all of those traditional capabilities that you need for operationalizing machine learning based applications. So you need governance, you need and observability, you need the data security, you need interoperability and the ability to work with different systems that might either be on cloud or on-prem. And so it's the organizations that have already been going through an quote unquote AI transformation or a machine learning or data science transformation are already, they've been down this journey. They've been building those capabilities. and we're going to encounter the new organizations or other parts of organizations that are going to that are trying to leapfrog this, only to realize that we can't escape the needs for productionizing enterprise grade applications and the need for productionizing enterprise grade machine learning applications that we've been struggling with and building for a really long time. So I guess it's the rich are going to get richer when it comes to who's going to be able to take advantage of generative AI. It sounds like, except the startups who might be able to.
Oh, it's so interesting. I think that there's well, if we're going to go in the land of prediction, here's what I would predict. I would predict that enterprise adoption, because of this dynamic, so ironically, the closer you get to operationalizing it in a way that, let's say, is externally facing, the more likely you are to produce outputs of a form that you already have governance and controls around. So now you already essentially have a set of benchmarks and regulatory compliance things that will get then slapped on top of your LLM. And it can be hard to make certain claims about the LLM, right? Because you train on a bunch of stuff. How much of that is in there? Can you really guarantee that if basic things like GDPR, if a customer wants to pull a record out, do you have to go and rerun and retrain the entire LLM? There's things like this that make it different. Right. Yeah. That expression, right? Right to be forgotten is a thing in a lot of the world, right? So I think these kinds of concerns are actually going to force enterprise, not force, but they will tend to orient the landscape for enterprise adoption of LLMs to really be on more internal facing tasks first. And so I think there'll be a lot of shadow IT things and data governance things and a lot of internal modeling and prediction things that that can be tackled with an on-prem or a governed sort of my own LLM, not uploading my stuff to any cloud, but just like my own thing. I think people are going to build some of those things to optimize internal business workflows and get good at doing that, because then you just avoid all of the external facing legal and regulatory kind of hurdles. And so that being said, I think the end user consumer facing stuff, it will be more startups YOLOing it. And that might be the way that this goes, is that, businesses are doing a lot of this internal kind of stuff. But then the next thing, my other prediction, is that the people who are best at doing this inside a business, those people are possibly going to be the ones to go and spin out their own startups or consultancies, because they know the shape of the data. They know what the businesses don't know, what the business problems, like what the business does and doesn't know about them. They, you really could have a professional class of boutique consultants in the long tail of internal business problems for every niche, for every set of domains, for every, type of, problem you might encounter in all these different industry verticals. I think it could actually change the landscape for technology adoption and innovation. But that's just a little, I call them entrepreneurs. And I would encourage people listening to this, if you are someone who is inclined to learn, if you're in a big business and you are in a line of business that you're not in the IT side, but in the LOB side, and you're working on certain problems, think about how you could use LLM technology to automate your job and the job of the people around you. And if you do that, what's the best way for you to vend that value back to your business, right? That's the kind of thing to think about that could be very interesting, could really transform kind of what work looks like in a lot of big businesses.
Interesting. So, I mean, it sounds like there's a degree of specialization when it comes to the models themselves. We'll probably be moving towards smaller models that are more task specific and more domain specific, and we should be expecting an ecosystem of those different, more specialized models. But it sounds like this is parallel to what will be happening on the business side of things, where we will be expecting to see a plethora of more specialized generative AI applications being developed and spun out of organizations that are then going after individual problems where, again, they can apply the learning, they can apply their knowledge of the data, they can apply their knowledge of and a certain reputational shield that you can have as an external vendor,
right,
for an increasingly broad class of generative AI problems.
Right.
Curious your thoughts, because several of the things that you touched upon feel like they have a mirror in the OpenAI saga, whether it comes to potentially people going off and starting additional companies that might have come up once or twice a year, or just in terms of that question of control: who controls the data, who controls the model, what do companies need? Do they need to deploy it on-prem? Can they, or from a third party vendor? I guess what are your well, obviously the saga that is unfolding in OpenAI probably hasn't hit its conclusion by a long stretch. We are probably just at the climax point right now.
Right.
But are there things that you've seen where you're expecting that organizations will change behavior after all of this flurry of activity?
Well, I think there is definitely a reminder to people that anytime they sole source a technology, right, that they have to consider the risk there. And that's not really a ding on OpenAI. It's the true for anyone. And I think most sophisticated businesses know this, right? They will make a bet here and there, but they always have. There's always an escape hatch, right? Because it would be irresponsible not to have an escape hatch. But I do think that, as a team, the OpenAI team as a company, they have such an incredible amount of AI talent there. They're building a lot of cutting edge things, but at the same time, there is a sense of this question of like what is the moat if people, whether it's Meta releasing Llama 2 and 3, or if it's entire sovereign states like Abu Dhabi releasing Falcon, the open source stuff, at the end of the day, it may not be the most cutting edge thing, but for a lot of business applications, you don't really need the most cutting edge, gigantic 100 billion or trillion parameter model. Maybe a smaller one could work, and maybe actually
if
a smaller
anything,
one's better.
Yeah, it might perform better in terms of latency, your ability to fine tune it, your ability to have ownership over it, and things like that, right?
Yeah, I mean, I know this is a bit of a digression, but just as a point, like I think people should understand that these giant models, they do amazing things, but you pay a lot for them. Like in terms of computational cost, you pay for what you don't use, right? And so in these models, when you go and you generate one token again, apologies if this is redundant for people listening to this, but every token you generate, it's doing essentially a gigantic amount of math on every concept, everything that's already embedded in the model. And if you have a model that's trained on the entire corpus of the internet, that includes Taylor Swift's birthday, that includes all of the text of the Lord of the Rings and Harry Potter and all the Harry Potter fan fiction. Every possible thing is in there. It's like basically driving a Home Depot or a Walmart to your construction site if you just need 2 or 3 things every single time. That's really expensive, right? And at scale, if you're a business, you don't need 99% of that. You might want some of the general language comprehension bits, but we're seeing that's pretty darn good with much smaller models. And then you want to put all of your business context on top of it, your own documents, your own emails and knowledge-based things, right? So I think what we're going to see is that, we're in the first inning of this whole thing, right? It's already been an amazing, a few rounds of amazing gameplay, but we're still in the first inning. And I agree with you. I think the OpenAI saga has not ended because this is obviously an interim board that's going to be doing some various things or whatever. But I do think that where the adoption of this goes is smaller, composable, governable, open source models that businesses then feel like they have control over their own destiny, which is then my answer to your question, right? At the end of the day, if you're a business person, you're responsible for managing your business, you want control over your own destiny. You don't want to hitch to even a big, powerful, amazing train like OpenAI. You don't want that to be your only ticket, right? And this is such an amazing transformational technology. And the options are out there for the open source models. You'd be remiss not to be doing something with those. And I think many of them are. I mean, from everyone I've talked to. So.
Well, it sounds like there's a whole host of predictions in what we've just been talking about. So one of them is obviously that moving towards a world where a lot more models specialized, fine-tuned for particular use or pre-trained for particular use cases, particular tasks and particular domains. It sounds like increasing enterprise maturity when it comes to leveraging these technologies in tandem with existing technology components, and then living within all of the both the processes as well as the other systems that it has to that have to integrate with. Um, it sounds like also some predictions when it comes to success with this, in the sense of, well, it's almost always impossible to escape a trough of disillusionment when it comes to any new technology. That's almost certainly that's almost an inevitability when it comes to this technology as well. And it might not be the fault of the technology; it's probably the fault of us having unrealistic expectations of just how easy it would be to use the technology. Yeah, other key predictions that you'd throw in there as well.
Well, it's already a lot. I think
that is already a lot.
Yeah, I do think that with this, because people are seeing the data, they know that, well, for a long time, and you know this better than anyone, right? In this industry, we've been talking about data is the new oil, from big data to then data science and all these other kinds of things, predictive analytics, that whole space. We've known there's a lot of value in data, and that businesses oftentimes are not very good at getting the value out of their data for whatever reasons. Sometimes technological, sometimes organizational reasons. But at the end of the day, there is value in the data. In most businesses, however, prediction is only one part of what the business does, right? Some people are more in the predictive space than others. Hedge funds, insurance companies, they're in the business of prediction. A lot of other businesses, they want to predict better to help kind of get the process flowing a little better. But I think with the AI transformation, people understand, if I have data, I am now in the prediction business. People are getting this now, which is really amazing that it's finally kind of coming around. But what's really interesting about this is that now they care about the security, because now it's not just a nice to have. It's not just a bunch of Python, R, SAS nerds in ivory tower. This is now going to be something that goes everywhere. And I think people are going to turn a bigger eye. Actually, I think just recently there's some governmental and regulatory stuff coming down about basically cybersecurity and AI connected together. People are very, very aware of how important this is. And just to give people a concrete example, for instance, if I hack your web server or I hack a database and I bring it down, or I steal the data and you see there's an intrusion alert, someone got into your database, and like, oh my God, terrible. Or someone hacked my website and it's down. Okay, terrible. But if I manage to go and inject certain bad values into your model, or I manage to go and tweak your model in some way that you're not aware of, and then you're simply not able to pick up on certain kinds of things happening in the world, that's a way different kind of attack. That's a much more pernicious thing to try to root out. You don't even know if you've been owned. I mean, that's really terrible. So I think people are, like I said, they're understanding how valuable their data is. Data is new oil. Now we actually have engines that can run that oil and get real work out of it. Okay, great. But now they're understanding how important it is to secure all of that, make sure everything doesn't blow up. So I do think there will be an emphasis on the security aspect, especially around the open source stuff, but then also around the practice of how data meets this open source stuff in a governed way. That's one of my predictions as well. We're going to have some high, like the industry always does, we'll have a couple of really high visibility issues that come out that then force everyone to think about it.
Yeah, absolutely.
But that's a prediction.
Well, I mean, it gets us to the risks of generative AI, and certainly folks talk about the risks an awful lot, but usually they tend to focus on the risks to people losing their jobs, or of dare I say it, Skynet, or other things that are a little bit more detached from the everyday. But what I hear from you saying is that, well, the risks are extraordinary, but the risks are, to a certain extent, operational risks. The risks are that we implement this incorrectly, we implement this insecurely, we do a bad job of leveraging these technologies. Not that they're going to be self-aware or something along those lines.
It's yes and. I mean, I definitely believe that. There are these operational risks, like I talked about, but the big societal ones, yes. I mean, not to get too philosophical on this call, but I really do think that there is a significant disruption for what would be traditionally considered middle-class, white-collar work that's coming. And I don't have any answers for how we solve that, but I think where we're going to first see it is when young college graduates are unable to find entry-level work, because a lot of what would have historically been entry-level jobs are actually not, they're not needed. And that's gonna be the first like gulp, like, oh wait, hold on a second. Then their younger brothers and sisters, why are they getting this expensive degree if they can't get jobs over here? I think that cycle is gonna start hitting in the next couple of years, and that's gonna be an interesting thing to see.
Well, these will be exciting times, no matter what.
No matter what.
Well, Peter, thank you very, very much for your time and all of your thoughts on this. It's a pleasure speaking with you yet again. And now we'll be looking to take questions from the audience. So please do not hesitate to go in and add your questions. It only remains for me to say, Peter, thank you very, very much for your time and sharing your wisdom with us.
Thank you so much for the great questions and the great conversation.
Hello, everyone. And again, thank you for attending our webinar. Unfortunately, Peter Wang had to drop, but instead we have a wonderful replacement for him. Chandler Vaughn leads product for Anaconda. He's the EVP of product. And so please do not hold back with your questions. We'd love to hear what is most pressing and important for you.
Thanks for having me, Kjell.
Thank you, Chandler. We've gotten a question in from Samuel Chapman, who's asking, do you think handcrafted reinforcement learning with human feedback band-aids will be able to cover and control most use cases, sort of 99% of the time just fine, without neutering the system as well? Or will issues become too numerous and unmanageable? Well, I told you in advance that we had a highly technical and informed audience, and Samuel is definitely living up to that billing. What are your thoughts on reinforcement learning with human feedback? Is it that panacea? How much will that be enough?
I don't think it will be enough. I do think that at least from my perspective, we are going to continue to chase accuracy problems with LLMs. And so there has to be some sort of additional verification in that and additional controls. We're not there yet, but the actual state of the art is actually improving at a rapid pace. But that's my perspective.
I would agree with that. And I think, I guess, how I describe it is that, well, there's no way that one single technique or method is going to be providing sufficient governance control over this. Back when Microsoft Tay came out and there was that big scandal around it, I talked about how, everything I learned about training a responsible AI model I learned from my kids. And I'm thinking about what are all of the different ways in which you prevent your kids from going out and getting into trouble, whether that be a moral code. Think of business rules that you would put around this, or going in and sanitizing inputs, sanitizing outputs. It's almost, yes, reinforcement learning with human feedback is definitely a powerful technique, but it's just one out of our broader arsenal, and there's a lot of old school ways in which you go in and provide robustness and around your application that you should be using as well. Other questions that had come in, one of them was Venu Gopal, who was asking about the validating the accuracy of AI-generated information. And I think this is from that broader approach of, well, even for general use cases, is there anything that we can do in order to minimize the amount of hallucinations that are on generally available information?
Yeah, this is one of the challenges. The beauty about GenAI is that it's accelerated massive creativity and brainstorming and various other things, but they also get confused. And so the accuracy risk in GenAI today is actually material. It's great for creativity. And there's no one's going to get harmed with some creative stuff, but you still have intellectual property concerns and you have this accuracy problem. So I think from a long-term perspective, we're going to see the state of the art move. Just as like my last answer, the state of the art is moving very, very quickly. But there has to be belts and suspenders, and I do think you're going to get some amount of specialization towards accuracy, and we see that with certain medical Gen AI and various other sort of controls at the back end. So do the actual Gen AI, but then have controls that actually validate those concerns. And I think you're going to see that on a more regular basis.
Mm. Well, I guess I'm also hearing about a lot of folks going in and just not relying on the model for providing factual information, but instead they're feeding the model either through RAG or some other method, and so constraining the domain of the answer that it can provide it. On the Data Science Leaders podcast, I had Stephen Kozlin, the educator, talking about how educators can leverage AI, and there it's very much one of, well, you're not leveraging the model to go in and help you to provide facts to your students. You're providing all of those facts. You're just leveraging a generative AI model in order to provide that engagement, that variation, that testing, that you can do one-on-one, but you wouldn't be able to scale as an individual educator.
Yep, I agree. The other thing to note, my opinion is that the big Titan models are going to get bigger and faster, and they will get larger with more knowledge. But I do think you're going to see specialization that will happen in the very long tail, for explicit domains with finance or manufacturing or medical or some of the sort of IoT. You're going to see explicit domain types of Gen AI coming out specifically for this problem, because the more data you feed it, the more it can get confused based on whatever context word or information got fed into it. So I do think that specialization is going to happen over time.
Absolutely. I'm curious on whether or not there's some evolutionary parallels here. It's often struck me that, well, we don't have super geniuses walking around us on a daily basis, and presumably that's not because evolution can't deliver highly intelligent organisms. It's because there's a trade-off to having that amount of general intelligence and knowledge in a creature. It takes a lot of energy in order to create and sustain. And I'm wondering whether or not there's a similar parallel here, that yes, sure, we can create 1 trillion parameter models, but it's more efficient to go in and train smaller models that are adapted to particular tasks and domains. And again, it's probably a stretch to go in and draw a parallel to biology and evolution, but it seems like maybe there are similar factors at play. What do you think?
No, I think that's absolutely true. There's power in specialization. I also think that the entry price for a 1 trillion parameter model is too high for many companies, right? And so I think that just by definition, the evolutionary analogy is actually important, because you can have a super smart being, right? But getting there is really hard. It's very, very hard and very expensive, and there's a lot of things that can kill it along the way. And so doing something at a smaller scale with specialized knowledge, I think is actually more valuable. At least time to value and it's much more cheaper. It's cheaper to get there. So.
Indeed. Curious your thoughts on the different methods for getting specialization. Is this always one of, or is there a dominant paradigm that's emerging between leveraging a small model, but together with RAG, versus a small model and going an even smaller model and doing a lot of fine tuning on it? Presumably, this is one whereby, well, it depends entirely on what it is that you're doing. If you're going in pharma and you're looking to go in and train a model that will predict something around a synthetic peptide, probably your general purpose model is pretty much useless there, and you're going to do fine tuning the living daylights out of this thing. Versus if you're going after a language problem, then might not need to do much fine tuning at all, and RAG is just fine. But are you seeing certain modalities or certain patterns shake out?
I think people are trying to figure out. I mean, they're starting with fine tuning. trying to give a large language model that is already trained some amount of context, real-time context in terms of additional answers. But I think that only gets you so far. I mean, it's good for creativity. It's good for channel shift, right? So companies that have like a support arm or something else, they want to educate a chatbot so that they can channel shift from answering the phone to having someone, having a chatbot answer for it. I think that's very valuable in those sort of unstructured cases. But to your point, where you get to highly complex and accuracy-driven problems, drug discovery, protein discovery is a good example. You have to train your own model, and so you have to pretty much start from the very basics in order to actually get there. And I think that's going to be a complex problem to solve for a lot of people for a very long time. I think there's whole industries that can spawn from that specific problem space right now. So
excellent. Well, I should have asked you this before, but before springing this on you, but I would love to find out more in terms of what Anaconda is doing on the generative AI side of things. So please feel free to say no if you don't want to answer a question around it. But if there are certain things that you want to direct people's attention towards in terms of how they can leverage Anaconda's offerings for generative AI, what should they be looking at?
Yeah, so we have it's a multi-pronged approach, as you might imagine. So we are a partner with Microsoft, and we are being embedded into Excel in Microsoft, and so that is just a Python story, and basically how do we bring data science to Excel and to the billions of users that use it. We are integrating a toolbox around that effort because most Excel users don't write Python, not yet, at least. So we're using GenAI to basically craft a way that you can generate very complex workflows within Excel through Python by just using GenAI, and that will use OpenAI on the back end, or an LLM that you have running in house. So you can repoint it. That's the sort of the broad stroke on that. But the more fine-grained approach is that we actually believe, from our perspective, we believe in democratized open source everything, right? And so we believe that the OpenAIs and Azures of the world will continue, Claude 2 will continue to grow and get bigger. But we also think that open source LLMs are going to have their rightful place. And so from that perspective, we are actually building what we call an AI launcher, which is basically to simplify that, being able to run an LLM locally, and be able to actually deploy it into your own infrastructure as necessary. This is really mostly to enable data scientists to pick and choose what LLMs are out there, to be able to build something around it, and then be able to deploy it in-house. I don't think, my personal opinion is that OpenAI will not own everything in terms of this LLM story. And so that is a way to disintermediate that, and it's core to the sort of Anaconda ethos around open source.
Well, I think every one of the advanced organizations that I speak with, when it comes to generative AI, are at the very minimum going in and evaluating different proprietary services, hosted offerings, as well as hosting their own, and are doing that cost benefit assessment on an ongoing basis, going in and saying, well, do the offerings that are out there have the cost profile, the reliability, robustness, accuracy that I need? And when I'm going in and spinning these up internally, what does it look like internally? And I'm seeing interesting patterns whereby occasionally they'll go for leveraging an externally hosted LLM for their text generation use cases, but then we'll be spinning up internally for image generation. And hosting that model internally, because again, it varies so much depending on the cost profile, latency, robustness, accuracy that you're trying to do. So presumably it's one where, sure, there might be a best one for your individual use case, but you're not going to know that upfront. You're going to have to go in and test all of these different ones and spin up your own ones to find that out. And you're probably going to need to be assessing this again, ongoing, as if nothing else, the models seem to be changing on a week-to-week, if not day-to-day basis.
That's right.
Week-to-week.
I mean that's the reason for the AI launcher is because it's going to be iterative. It's a very fast-moving market currently in terms of the changes. I think that people are still doing this cost-benefit analysis of, what are the easy, low-risk use cases that I can just put on OpenAI or Claude 2, but there's still sensitivity around the security story, like what data would be exfiltrated from that if I actually put my data there. What kind of controls and boundaries can I actually implement on the LLM? What guardrails can I put? Is there a way to put a model firewall so that I don't exfiltrate PII somewhere accidentally? Somebody has access to HR data that they shouldn't have access to, whatever those things are. I think all of those complexities are making their way through the system. Large enterprises, I think, are still in this evaluation phase. They're trying it for some small things, but they're really trying to figure out what this new sort of LLM stack looks like. And that includes things like I said, a model firewall or a prompt library. These are not sort of the normal MLOps things that you would have, at least not in the sort of classical sense. But these are the things that we have to worry about now.
They will become part of the normal MLOps set of tooling that we expect to need, hopefully. But Chandler, thank you very, very much for joining us. Thank you so much to Peter Wang for sharing his thoughts, and thank you to everybody for joining us on this webinar. Please stay in touch.
Thank you, Kjell.